Hey, what's up guys? Rob here from BreVITy, and in this video we are going to solve the longest substring without repeating characters problem on LeetCode. So let's get started. Welcome to week 4, the sliding window week. In this week, we're going to talk about more advanced concepts than the ones we dealt with in the previous weeks. But before that, if you're new to the channel, BreVITy is all about helping our peers conquer DSA and getting into one of those FANG companies. We release videos almost every day, so if you haven't subscribed yet, be sure to subscribe to make sure you don't miss it. Now Siddharth has made a beautiful video where he explains the problem statement and the algorithm that we're going to use to solve it in great detail. I will only be writing the Java code in this video. So if you want to know how the algorithm works internally, make sure to check this video out. I'll wait. Okay, are you back? Let's continue. Now here is the problem statement on LeetCode. Thankfully, it's a bit short this time. Given a string s, find the length of the longest substring without any repeating characters. Now what does it mean? I think it pretty much says it for itself, right? So they'll be giving us a string such as this, ABC, ABC, BB, and we're expected to return the length of the maximum substring without any repeating characters. So for example, in this case, ABC will be the maximum substring without any repeating characters. Because if we try including something else, like if we want to include this A, we cannot do that because A is already there in the substring. So that is why we are going to return 3, which is the length of ABC. Similarly, in example 2, when it consists of only one single character repeated multiple times, the answer is obviously going to be only 1, because that will be the length of the maximum substring without any repeated characters. So now that we have understood the problem statement, let us try to implement the algorithm which Siddharth explained in his video. Now the first thing that you might think of when you look at this problem statement is going to be the brute force approach, where you're going to be using nested for loops. So we're going to check each and every substring which is present in the string and then verify whether each character in this substring is going to be unique. This is a brute force approach, and while it might work, the time complexity is going to be O of n cube. Why O of n cube? Because it's going to be O of n square when you're going to have nested for loops, and inside the nested for loops you are going to have to check if this substring has unique characters present in it. So you're going to have another for loop inside in order to check that. So the overall time complexity of this solution is going to be O of n cube, which is not ideal in our case. So we are going to attempt to use the sliding window approach, which is going to reduce the time complexity from O of n cube all the way to O of n, which is a linear time complexity. Step 1. Implement the algorithm. Now I'm going to be briefly explaining the algorithm that we'll be using to solve this problem in case you didn't check out Siddharth's video. Now the first thing we'll be doing is to initialize the 2 pointers I and j, which are going to be the left and the right pointers which denote the window. We will also be declaring a flag variable called maxLength in order to store the value of the maximum length of the substring which we have found so far. We'll also be declaring an empty set in order to store the characters which are present in the current substring. So let me declare the variables which I had mentioned so far. So int I is going to point to 0, int j is also going to point to 0, and int max length is also going to point to 0. Next, I'm going to declare the hash set. So the way we do that in Java is hash set of type integer is set equal to new hash set. Alright, and I'll also declare a variable length which is going to be s.length. We will then initialize a while loop which will run all the way from j equals 0 till j reaches the length of the string. Now we know that in a sliding window concept we'll have two phases, the growing phase and the shrinking phase. During the growing phase, we will check if the element which j is pointing to is present in the set. If not, we will add this element to the set and increment the value of j. We will then check the length of the current window and compare it with the length of the maximum window we have got so far. If the value is greater, we will replace the max length with the current window size. If not, we are simply going to skip and continue to the next iteration. So let's do that first. While j is less than length, if set.contains s.car at j, if not set.contains s.car at j, in this case we are going to be adding this character to the set. So set.add s.car at j, and then we have to increment j. So we're going to do j++, and then we'll check max length is equal to max.max of the current max length and the current window size, which is nothing but j minus I. So in case you're not aware of what this math.max function does, what it takes is two parameters inside, and the left hand side max length will contain the value whichever is greater between these two parameters. It's as simple as that. So that's it for the condition for if the set doesn't contain. At the same time, if the element which j is currently pointing to is already present in the set, then we have encountered an invalid window. This is because the element which j is currently pointing to is already present in the substring. So in this case, what we're going to do is we're going to remove the element which I is currently pointing to, not j, I. And then we're going to increment the value of I. So we're going to keep doing this until we encounter another valid window. And once that is achieved, we will stop the shrinking phase and once again continue to the growing phase. This iterative process will keep repeating until j reaches a value which is the length of the string. So let us implement the else condition. So else, what we're going to do is we'll use a set.remove operation. So set.remove s.car at I, and then we're going to increment I. And outside the while loop, what we're going to do is we're going to return max length, which is now contain the maximum length that we have encountered after this iterative process. So let us try running the code and check for any compilation errors. Okay, so car cannot be converted to integer. Okay, so let us begin the debugging phase, which is step 3. So what I've done over here is I've declared the type of the set as integer. Whereas in this case, we are going to have to include characters in the set. So that is quite a simple error. All you have to do is change it from integer to character. So now let us run it again. Okay, so now we can see that the sample test case passed. So now let us move on to step 2, which is going to be checking for edge cases. Now, one possible edge case that you might think of is what if the length of the string is 0? So if the length of the string is 0, we can conclude that the answer should be 0, right? Because the longest window is also going to be 0 because there are no characters in the string. So in this case, we can see that the max length variable is initialized to 0 and this while loop condition is never going to return true. Because j is also 0 and length is also 0, so this condition is false. So we're going to directly return 0, which is the expected answer. So we can conclude that we have already implemented the edge case logic in this code itself. So now let us move on to step 4, which is optimization. Now, since it's already an O of n solution, there are not many ways in which we can optimize this. There is one approach we can do using maps, but that is beyond the scope of this video, so I'm not going to cover that concept. What we can do is the post increment operation in Java. So if you look at this, what we're doing is we're adding this particular character and then we're incrementing j. Now if we wanted to be a bit fancy, we can do this in one line by simply removing this and adding the j++ here itself. And this is called the post increment operation. We can do the same thing over here with I++ and remove this line entirely. And we also know that inside an if-else loop, we do not need any braces if there's only one line inside. So we can remove this as well. And now let us try running the code, and we still should be getting the same output as shown over here. Now let me submit this code. We can see that all the test cases passed with a runtime of 6 milliseconds. Now let's move on to step 5, time and space complexities. Now the time complexity of this solution is going to be O of n, which is a linear time complexity. This is thanks to the sliding window approach, which really reduces the time complexity. Now what about the space complexity? It's not O of 1 this time. That's because we're using this extra set over here, which is going to increase our space complexity. So in this case, the space complexity is going to be O of n, where n is the length of the string. And that's it for this video. Thank you so much for watching. I hope you guys enjoyed it. This was Rob. You're watching BreVITy. Thank you and goodbye.